My name is Nate Burley. I am a chemistry and special ed teacher. And as Mr. Johnson said, we will be explaining things to you, not just hopefully wowing you. And our first reaction is actually the thermite reaction. It is between iron oxide and aluminum. Now, if you have iron oxide, a compound, and aluminum, a single element, react together, I'm sure at least 95% of you can tell me that that's a what kind of reaction? I heard single replacement. I like it. Let's do it one more time though. I'm sure at least 95% of you can tell me that it's a?
Single replacement.
Oh, I love it. You're all so very, very astute. But this reaction doesn't just take place on its own. You put the two together and it's not so fun. So many times you need to provide some energy to a reaction to get it to go, right? So the activation energy in this case is provided by a little physical force. Sometimes.
Yeah, like a minute.
Okay. That's good advice. I didn't mean that one.
Not good, but better.
All right. This is it. This is the ear blaster. Wait. There we go. That literally made no difference. All right.
There you go. Yeah.
All right, pretty good. And as you can see, this is a pretty vigorous reaction. Thank you. Okay. We're just idiots up on stage. Applaud for the science, not for us. But as you can see, it's a pretty vigorous reaction, right? It rips the aluminum foil in half. It's so vigorous, in fact, that this reaction is used to make a lot of noise and weld railroad rails in place. So you're out there, apparently a railroad man or lady, and they use this reaction to literally make iron to weld railroad rails in place. It's pretty cool.
There you go.
Yeah.
Our next one's called the traffic light demonstration, and this is a pretty cool one. What I have here is a solution, an indicator called indigo carmine. Now, indigo carmine has three oxidation states. It has a low, a medium, and a high, all of which have different colors. And the reason why this is called the traffic light demonstration is because, well, at the lowest oxidation state, it's yellow. If I oxidize it by giving it a little shake, I can dissolve more oxygen in there, and we can see that the indigo carmine will oxidize to a slightly higher oxidation state, which is red.
Wait, when it's a traffic light, what does red mean?
Red means stop.
Red means stop, okay.
Yeah.
Okay.
Green means, of course,
Go.
go. Yellow means no.
Slow down.
That's right. And if you noticed, if we wait around a little bit, it actually goes back to the original lower oxidation state yellow, because what I also have in there is a reducing agent called dextrose, or sugar, and it will reduce it back to its lowest state. So if I give it a little shake, it turns red. If I give it a vigorous shake, I can really oxidize it, and it turns green. And if we wait around a little bit, the sugar kicks in.
A little bit.
A little bit.
A little bit.
Trust the chemistry.
I trust you.
It'll turn red. And if we wait around a little bit more, it'll eventually turn back to its original yellow color. So we'll let that sit around a little bit, and you can keep an eye on it. I have another one here.
Oh, can I do this one?
Sure.
Okay. So, you know when you said dextrose or sugar?
Yeah.
That actually took me again. What we have in here is a very similar reaction. This is in fact supposed to be methylene blue, but it's also methylene kind of old, so it's pink. So again, we're just adding oxygen. We get it up to a higher oxidation state, and then we wait, and it comes back to its more clear state.
Okay. Let's go.
I like that. Okay.
The next one we have is a little bit of a little dry ice demonstration here. What we have here are three different bases. We have a dilute sodium hydroxide solution. We have a not so dilute baking soda or sodium hydrocarbonate solution, and we have a really not so dilute calcium hydroxide solution. So three different bases, three different concentrations. And what we have here is a little bit of universal indicator, which again will change color, not based on oxidation state this time, but based on its pH. And if we can put something in it that turns it from basic to acidic, we can see what happens to the colors. So what we have here is a little bit of dry ice, and if you dissolve dry ice into the base, it will turn into carbonic acid, which will lower the pH, increase the acidity, and we can see what happens to the color of the indicators.
Oh, this is also a fun race for us because we're never quite sure which one's going to change color first or last. So if you want to place your bets, by all means, go ahead and place your bets now.
So here we go, ready? 1, 2, 3, go.
I cheated. Okay, first.
Ooh.
Who's the left?
That was quick.
That's quick.
Let's do that. That's,
I think he had more pieces.
okay, that one's about to go. So.
So we notice it goes from the blues, the purple blues, to the greens, which is neutral, and eventually we let it sit around for a little bit, it'll turn into the reds, oranges, and yellows of the acidic spectrum.
Range of universal indicator. And what's actually really interesting with this one is, I don't know if you can see that back there, but as it's about to bubble over, because I apparently put slightly too much in, you get actually a more basic situation up here. So the indicator has turned back to blue. Again, this was a saturated magnesium hydroxide? Calcium hydroxide. So some of that has come out of solution because it's gotten so cold, and you get a much more basic environment up here, and then more acidic down where the dry ice is.
And we also notice that the strongest base is the last one to turn, which makes sense, and that one just turned as I was talking, so that's kind of cool.
That was pretty cool.
Yeah, good timing.
It's like we planned it.
Yeah, we had dry ice, right?
We do.
Dry ice is really cold.
It's very cold.
I've always seen people.
No, wait. I don't want to do that.
Oh,
Do you want to do that now?
no. Let's do it a little bit later.
Okay.
So on our next one.
Okay. So this. Is that the one we're doing? It's a pickle. Are we doing the pickle?
Yeah, let's do the pickle.
Why are we doing the pickle?
Because it's tradition.
Battery.
This is a really stupid tradition. Okay. It's a pickle. Yeah. I know. Did you make that pickle?
I did.
That's really cool.
2 years in the making.
So it's 2 years in the making?
2 years. This is a 2-year demo.
What'd you put in there?
Vinegar and salt.
You mean acetic acid and sodium chloride?
That's the one.
Okay. So Mr. Johnson's going to plug in our apparatus here, and hopefully we'll get to see the effect of an electrolyte on a. Yeah, go crazy.
Yep.
We'll get to see the effect of an electrolytic solution as far as carrying a current. Oh, I hate this demo so much.
Yeah.
It's kind of green.
It's okay.
It's a little green.
Yeah. Not sure if it's 2 years worth of.
Yeah,
We can do that.
Yeah, I can do that. All right, cool. All right. So, would you mind unplugging that, please? Acids, bases, what's the word I'm looking for? Ionic solids.
Yep.
Anything that will dissociate into a positive and negative ion in water will give you an electrolytic
smells
solution,
good.
which means that it's possible to
Burnt
carry
pickle.
a charge across that solution. So what you see is the pickle sort of light up in a very pickle. Why do we do it with a pickle?
I don't know. And I really don't like touching pickles anyway, but what we have here, we have a really cold solution.
That does look cold.
Yeah, and I thought, usually people would do this with liquid nitrogen. We don't have liquid nitrogen. What we do have is ethanol with a very, very cold substance on stage, which we use for our dry ice. And because ethanol has a lower freezing point than dry ice, we can get the ethanol very, very cold. And what we can do is we can put things in it
And freeze them real quick.
and flash freeze
Oh, that's the flash.
our pickle.
Who came up with this?
I don't know. Every once in a while, you have a really good idea.
That once in like every 2 years?
Yeah. But that good idea is so good that it's worth all the bad ones.
I know. Well, I wouldn't go there. Do I get to hit it?
And what we have is a very, very cold pickle.
It's a cold pickle.
You know, I don't want to do the pickle, though.
You want to do the pickle?
No, because what we do is usually do like bananas.
That's not tradition. Bananas is tradition.
Right, yeah, we
You're
usually
right.
smash the bananas. And I
Yeah.
just happen to bring a banana with me.
Yeah. All right. I love bananas.
But wait. Dude,
Well, I said I love bananas.
you ate the banana.
Yeah.
When did you eat the banana?
It was right before the cookie.
All right, well, luckily I bought another one.
Oh, was that the one that was in your book bag?
Yeah, the green one.
Yeah, I got that one.
I don't know what to do.
Well, okay, so this may be kind of a strange request, but does anybody out there happen to have a banana?
I have one.
You do? Oh. It was,
You see one, right?
we really only needed the one, but that's okay. That's all right. That's a lot of banana. All right.
And we just need the one.
We just need it. All right, so I'm gonna plunk that.
Well, it's lucky that they came prepared, huh?
That is very, very lucky.
That's
That
fortunate.
is really very fortuitous. Ooh, that's. Oh boy, that's pretty. That really freezes up.
That freezes up pretty good.
That's not gonna like that.
Yeah. So if we let that sit around for a couple seconds, what happens is that, like I said, it flash freezes. This ethanol is so cold that the banana will freeze in a matter of seconds here.
You down?
He was gonna grab it, isn't he?
Why don't you give that a smash?
I give it. Oh, I get to smash it.
You can smash it. That's
I've
your idea.
always wanted to do this. Okay. You sure I should do it?
Go.
Okay. That was okay.
It's pretty good.
That was okay.
Mind if I try?
I do not mind at all.
So,
You gotta hit it like you want to hit it. You do the same thing with the thermite.
there we go.
That's fine.
There we go. Okay, excellent. Let's move on here.
Wait, you want to do that?
Let's move on.
Okay.
All right, so what we have in this one is called the luminol reaction. This is one of my favorite reactions just because it just, it's visually stimulating. It's also just, it's a really cool demo. If you mix these two reactants together, we have our peroxide reactant, and we also, are you eating the banana? And we have the copper sulfate solution. And if you mix them together, you get the compound that you, what are those creatures in the bottom of this? You know what I'm talking about?
Coelacanths.
No. They're light. They're flat. They're just like they're the bottom of the. You know what I'm talking about? They're just like bottom feeders.
Oh, the ones that just wait around for unsuspecting prey. Chemistry team.
No. You don't have to put them in the ocean.
Oh, the
The
lanternfish.
Lanternfish, that's the
Lanternfish,
one.
yeah.
So this is actually the
Like in
reaction
Nemo.
that the lanternfish take advantage of, and this is what lights their lantern. If we can get this stage as dark as possible. Is that?
Yeah. Wait. You wanted funnels, right?
We wanted funnels, yeah.
Okay. So can you help me with this?
Yeah.
Okay.
All right, ready?
I am ready to do that. Wait, should I be wearing gloves? You're wearing gloves.
No, I just got it from the phone.
Okay.
Maybe we can do a little bit
Are you
darker.
sure?
Yeah.
Okay.
We get a little bit dark. We get as dark as possible. Is that possible?
Okay.
We brought a big enough waste container, right?
I think. Did you put the stopper in the bottom?
Yes.
Guys, is the stage glowing right now?
Yes.
There we go. Pretty cool. Yeah, that's good. That's good.
Okay.
And my friend, the stage is yours.
Oh, yes. All right, so this next demo, Matt, please have this. This next demo is called the Golden Rain. Many of you may know or may not know that chemistry is all really based on alchemy. Alchemy, right? Many of us have heard of this, I'm sure, from video games or from anime. But the original, I didn't think that was going to be funny.
You got it.
Okay, cool.
Put that one in the back.
Anime. It worked again! This is a good audience. All right. So what the original point of alchemy was, though, was to turn more base metals into gold. Now, they didn't mean basic, like high on the pH scale. What they meant was just lower metals like tin, copper, lead really was the gold standard of what they were trying to do, was to turn base metals into gold. So what I have in here is a solution that actually has some, when I say some, I mean a ton of lead iodide in it. And I made the lead iodide solution. Oh, this needs to cool.
Yeah, I mean, if you just dump a bunch of salt in it, I think it'll be just fine.
Just salt?
Yeah, I mean, some of the salt will be.
Oh,
Yeah,
okay.
let's give it a shot.
Okay. Yeah? Yeah. Okay, all right. So lead nitrate, we put a little potassium iodide in there, and what we get is, oh, man. No, you know what it is? It needs to cool.
Okay.
Yeah. So I'm just going to put it, this is going to take forever to cool.
I mean, we have really cold things, I think, somewhere around here. Something that's like really, really cold. Like, we just used something that was really, really cold.
What?
Yeah.
Maybe in the funnel?
What was it?
The dry ice!
The dry ice.
dry ice is
That's
really, really
right.
cold.
Oh, that is true. Okay, all right. So what we have in there is lead iodide and some potassium. Potassium iodide and lead nitrate. And let's see if we can't cool this down a bit. And like the alchemists of old, turn our lead solution into gold.
It's good that we got the big bag.
I think that's a good thing, yes.
Just let that sit around for a little bit.
I think it has to sit for just a minute.
Yeah.
Do you know why I did that?
I don't.
Because it's cool. Okay. All right. So, this next demo uses a dye called fluorescein. Fluorescein is a marker dye that's used in biological tests, and apparently my stir bar has, what has happened to our power, sir? Do you know? No, it's all on, but it's not on. If any of the stage crew can hear me, our power bar seems to have become dispowered. So we'll just move on.
Yeah,
we
we'll
could
move on.
reset, maybe reset.
No, we'll move on.
All right, so we'll move on.
This
We'll
is
go
better-
on
this
to
is
this,
better anyway.
and we'll. That's true.
What we have here, this one is called the Barking Dog Demo. And what we have is a little bit of ethanol that's been evaporating in various glassware. We have a couple of eudiometers, various sizes and shapes. We have a graduate cylinder, we have an Erlenmeyer flask, volumetric, and we have this unnecessarily large boiling flask. And the ethanol has been evaporating for about an hour or so, creating vapors. And
Is unnecessarily large a technical term?
I think so, yeah.
Okay, all right.
Yeah. And
He's got power again.
the reason why it's called the barking dog as well, I guess we'll just kind of find out.
Yeah.
So here we go. This is for you, sir.
Should we tell them what happens when you put a match into ethanol?
Well, I think we'll find out the other way.
That's quite true.
Right?
I am ready.
First up
Yay, thank you.
is the eudiometer.
The
right?
eudiometer, the barking eudiometer.
1, 2, 3.
Hello.
It wasn't so much a barking dog.
It was like a whistling canary.
It's like a whispering squirrel.
Whispering squirrel. I like those.
So next one up is our
That's definitely
leader, our leader.
I got it.
Our leader graduated cylinder. Let's see what this one does.
I think this one's gonna bark.
All right. That was like a bottle whoosh.
It was like a bottle whoosh. It was only like if you could bottle whoosh.
Next up is our 4,000 milliliter Erlenmeyer flask. That was promising.
Is our necessarily large. Oh, I'm so sorry, sir.
Yeah, this one. Yeah.
Erlenmeyer flask.
Go for it.
Would you mind taking this? Oh yeah, thank you. Should we call this one?
Wasn't final.
Okay.
Whoa.
There we go.
I was like the mom's mad. I'm getting out of the room.
I'm excited about this one. This one is stubby at the bottom here, and it kind of gets narrow and tall at the top. So
Like me.
we'll see what happens on this one here. Can I do this one? Yeah.
Absolutely.
All right.
Okay.
Oh.
Oh, that was like Dad's coming into the room. That's right. Okay. All right.
And finally, we have our 5,000 milliliter boiling flask.
Should we do this one together?
Sure.
I like that. Where'd you get that?
I found it
Where'd you find it?
in my lab.
That's like you should have expected that exact thing.
All right, ready?
Yes. Wait. No. Wait. Yes.
1, 2, 3.
Right.
Oh.
Oh, that was like a screaming little sister. Screaming little sister. I like that. That was really good. So none of them really barked like a dog, but I think they were pretty neat either way.
Yeah.
Let's do floors.
Sure. Yeah.
Okay. Concentration. Is very, very important as a chemist. Not just so that you can study 2 units the night before the test, but so that we don't accidentally harm people, right? Because chemistry is involved in so much of our daily lives, and the incorrect concentration can mean the difference between a healing dose and a fatal dose of a medicine. So just to sort of demonstrate that there are very large differences that come with differences in concentration. Anyone that can see the color of that solution, would you please shout it out?
Red.
Red, absolutely. Pretty undeniably, very, very red. But that's at a very high concentration. Again, this is fluorescein dye. It's used in a lot of biological testing.
12 months.
But it's used at a much, much lower concentration so that you can actually... Oh, could we get the stage lights down a bit? Thank you.
Okay.
I had like a lighting guy.
Ooh.
Follow me around, that would be wonderful.
I wish I had a music guy follow me around.
That'd be really cool.
I have like P music.
You're really musical, you should just carry your banjo around. I mean, your ukulele. What do you play? Mandolin. Okay, so there you go. The very, very strong difference between a concentrated solution and a more dilute solution. Now, this isn't really very chemistry, but can we do the waste thing now?
Oh, yeah.
Okay. And when I say can we do the waste thing now, I mean, can you hold the black light while I don't do it?
Sure.
Okay, cool. Here, I don't put it. Okay. We're really only doing this because it looks cool, so. You're all. Ooh, that's very hard to hold.
Yeah.
If only we had a physics teacher up here to show us how flow works.
Things fall.
Yes, gravity works, things fall. We've proven yet another scientific known.
All right.
Okay.
Hey, in honor of our last show here, what do you say we actually plug the light box in this time?
Yeah, okay.
Yeah.
I like it.
Yeah. All right.
Okay.
Here we go. Our next and final demonstration here is called the rainbow demonstration, or what we have here is a couple of indicators like before, and we have pre-made some acids and some bases, and we're going to try and get the indicators to go back and forth in the presence of an acid and a base, and we can see what the color changes are.
Okay. I totally forgot to say yes. I would have gotten her name on it.
There you go.
Okay.
All right, are we ready?
We maybe would be more dramatic if we had music to go along with this.
This music, the sound guy.
There we go.
Someday I wish upon a star and wake up where the clouds are far behind me. When trouble's not like lemon drops away above the chimney tops, I swear you'll find me somewhere over the rainbow. Birds fly, birds fly over the rainbow. I don't know why can't I? If happy little bluebirds fly across the rainbow, I know I can. Why are there so many songs about rainbows? What's on the other side? Rainbows are visions, but only illusions, and rainbows have nothing to hide. So we've been told, and some choose to believe it. I know their own way and see. Someday we'll find it, the rainbow connection, the lovers, the dreamers, and me. We said that every wish, but we heard an answer. A wish on the morning star. Somebody thought that, someone believed it. Look what it's done so far. What's so amazing that keeps us stargazing? What do we think we must
Interesting.
see? Someday we'll find it, the rainbow connection.
Is that it?
I think that's it. Oh, we got one more.
We do?
We got an encore.
We do?
We didn't ask for an encore, but we're gonna do it anyway.
I like it.
Yeah.
Okay. They don't ask for tests either, but we do that. Right.
Well, I mean, the barking dog went off so well that I think we got to do one more big one. It was great, but none of them barked.
They didn't bark.
They didn't bark. We need a bark.
We did little tube, bigger tube, giant flask, ridiculous volumetric, and then mega boiling flask.
Yeah.
What's left?
How about this guy?
I like that guy. Yeah, absolutely. That's all. Wait, before we do that, our alchemy experiment has worked. I'm so excited for that. So we have turned our lead into gold. And if anyone cares to take any of that precipitate home and try and spend it, don't. Okay. How are we going to do this?
Yeah, well-
Can you give me the other hand? The other hand. Yes, please. Yes. chemistry teacher.
No, I was out of breath for that. I was out of breath for that last time. I really was.
That didn't take much effort.
It's a
Why
good
were you
thing.
out of breath?
It's a good thing I run once every 6 months.
Okay. So, yeah, lift please. There we go. Much like the other barking, yelling, screaming, tweeting experiments that we had earlier, this relies on the very same principle: a flammable liquid which has vaporized a bit. It's actually go right on the flammable liquid which has vaporized a little bit. The flame front, instead of just being free to do whatever it will, is confined to the tube or whatever else we use. So this is basically the same principle, but hopefully a slightly bigger bar.
Yeah, I see.
Yeah. Can we get the lights on? Maybe let's go with the house lights as well. Okay. Okay, that's true. The ethanol man does not care whether or not the lights are on or off. All right.
You also might notice that flame was green. It was because before the show we kind of laced the inner of the tube here with a compound called copper sulfate, which upon getting excited and electrons jumping and falling forms a green color. So there we go.
Absorb energy, jump up, emit light, jump
Fall back
down.
Look at that.
We've always wanted to do this sort of experiment on stage. It's you may remember it as the flame test. But to make it sort of more exciting than sticking a splint into a flame, we decided to put it inside of a ginormous tube.
Yeah, we can't have 12 of those in the lab though. It's just insane.
Challenge accepted.
Thank you so much for coming.